This is the walkthrough video for PCTC 2021, round 2, question 6, light filter. So I actually did this question 3 years ago during the real competition, and I remember this is the first question I did in my team. Anyway, so this question is quite unique, but once you kind of figure out this trick, then it's not too difficult. So let's take in our inputs. The first two inputs are easy, they're just two numbers. Let's call them, what are they? That's going to be columns and then rows. So columns is going to be our first input, and rows is going to be our second input, and of course they're both integers. And now we need to build up this grid of essentially blocks or not blocks. So let's create a 2D list, and I'm going to call this list, let's just call it grid. And for as many rows as there are, so for I in range rows, I want to take in an input, but actually I don't want to just input this as a string and add that to our grid. I want to go through every element in our input string and convert it into a number, because they're all 0 or 1, and 0 and 1 as numbers, as we'll find out later, they're actually going to be much more useful to us than just dealing with the string. So to convert all of them into numbers, there are of course multiple ways. I'm going to use the list. So I'm going to say int thing for thing in the input. And to this list, well, with this list, I want to add that to our grid. So grid.append that entire line of code. So at this point, we've now built up our full grid. It's taken all of our inputs, and we've also got the rows and the columns. So now we can work on the algorithm itself. Now, so let me tell you how I'm going to do this. Sorry for this delay. Okay. So if we have a grid like that, and let's say that kind of represents this 6 by 10 grid in the example input, what we want to do is we want to chop it down in the center, both horizontally and vertically, like that. And we want to go through each cell. For example, let's assume there are this many cells. We're going to go through each of those 12 cells in our first quadrant and also compare it to each of the 3 other cells in the other 3 quadrants for each of those 12 cells. So for example, when I look at this cell, I also want to look at the cell that's going to be over there, and the cell that's going to be over there, and the cell that's going to be over there. Because these 4 cells, according to the problem, when you combine these 4 quadrants, these 4 cells will overlap with each other. And we need to determine whether any of these cells are equal to 0, i.e. are any of them blocked, and if they are blocked, then we know that this cell won't have light visible once all of these 4 quadrants are stacked on top of each other. And we do that same process for each of these 12 cells, and each time we check one of these 12 cells, we also check the other 3 cells from the other 3 quadrants. Now, you can kind of try and simulate this in Python and write code to do that. I think that's a bit clunky, and so what we're going to do is we're going to use mod functions, which are an amazing feature of any program, and they can really help in problems exactly like this. Okay, so what we want to do first is we basically want to write code that gets us through every cell in, for example, the top left quadrant, because we don't want to go through every cell of the entire piece of grid, only the top left quadrant. And how do we determine that? Well, if we take we need to take our columns and our rows values and chop them each in half. So let's do center for columns, and that's going to be equal to columns divided by 2. I'm using integer division here just to keep everything as an integer, because even though it's an even number, and therefore it will be a whole number, if we just write that, then our output is going to be a float, whereas we actually want an integer. And I'm going to do the same thing over here, but for rows instead of columns. And so just like that, we now have the central axes for each of our columns and rows. And what that means is we can now write our nested for loops that go through every cell in just the top left quadrant. So let's do let's call it, I don't know, for C in range up until center C, and for R in range up until center R. And so we're just going, so this code is all we're doing to go through every cell in the top left quadrant. because of course the cell is now bounded by, sorry, the quadrant is now bounded by these two green axes over here. Okay, so as we go through every cell, what did I say we need to do? Well, we need to access the information not only from that cell in that quadrant, but also the other three cells from the other three quadrants. And this is where the modular functions come in. So this current cell is obviously just going to be, so in Python, this is going to be row, then grid, and that's our current cell. What's a corresponding cell from the top right quadrant going to be? Well, that's just going to be, grid is the same row, but to the column, you take the column and you have to also add the center column. So you're taking the column and then you're just shifting across. In this example up here, you're shifting across 4 cells to get to your corresponding cell from the top right quadrant. And we can see that here. We're just moving across 4 cells in the same row to get to our next quadrant. And we can apply the same concept in the vertical axis as well. So we can just go 3 cells downwards to get to the corresponding cell in the bottom left quadrant. And of course, I'm sure you would have known by now, to get to the corresponding cell in the bottom right quadrant, we do both actions, because if we both move across our row and down the columns, we then reach that cell. And so just to type that out, this example from that cell, that's going to be equal to grid row plus the center rows, because you want to shift it all downwards, but it's the same column. And then finally, the bottom right quadrant cell is just going to be both transformations done at the same time. So it's both the row shifted and the center shifted, like that. And so now we have our 4 linked cells, or our 4 cells that are going to be stacked on top of each other from each of our 4 quadrants. And now we need to check, are any of these equal to 0? i.e. are all of them equal to 1? Because if they're all equal to 1, then light can pass through it, and therefore we need to keep track of that. Now, of course, there are loads of different ways of doing this. The obvious one is just to write an if statement by saying, is that equal to 0, is this equal to 0, and so on 4 times. But you can use this command in Python called all. And what all does is you have to give it a list or a tuple, whatever. Let's give it a tuple. And if every item in this tuple is true or equal to 1, then the whole all statement is also true. And so if I just copy paste all of these in here, and so what I'm doing is I'm creating a tuple that contains the value of each of our 4 corresponding cells. And so now this tuple will just be a tuple of 0s and 1s. And this is quite a long if statement line. But essentially, if all of these values are equal to 1, then this whole if statement returns true. If even just one of them is equal to 0, then the whole if statement returns false. And so that's a really neat trick to very quickly identify whether everything is true or whether something is false. And if everything is true, then that means we have found a cell where light can pass through all of the 4 layers. And so let's add that to our total variable. So total plus equal to 1. But we need to actually create a total variable first. So let's do that up here before our loop. And total is initially set to 0. Then every time we find a cell where light passes through it, we can add 1 to total. And so of course the final thing to do is just to print our total. Yep, and this just highlights the power of kind of dealing with modular arithmetic or adding. I mean, we haven't actually used the mod symbol here, right? But we've used the same idea that you do use in modular arithmetic to kind of simplify this problem.